Okay, students, on this group we're going to be going over some examples on operations and composition of functions, all right? So let's go ahead and consider the learning objective for this lesson. So the learning goal today, you're going to learn how to perform operations on functions. The four operations we're going to do are addition, subtraction, multiplication, and division. And then you learn how to find the composition of two functions. All right, composition of functions. Let's start with the operations. If you see the formula f plus g of x, that simply means that the x can be distributed to the f and the g. This is a convenient way of writing f of x plus g of x. The same idea applies to the difference of functions. If you have f minus g of x, simply means f of x minus g of x. For the product of functions, f times g of x is as though you're distributing this x to both of these functions, f of x times g of x. And also for the quotient, if you're asked to find f over g of x, it's simply f of x divided by g of x. These are shorthand ways of writing indicating the operation of functions, and this is actually what we will apply to the formulas, okay? All right, let's consider the first question. Let's say we have two functions, f and g, and f is 4x squared plus 3x, and g is 3x to the third minus 2x. However, if we're asked to find the four operations using these two functions, f plus g, f minus g, f times g, and f over g. Let's do f of g for f plus g first. F plus g, as indicated in the formula up here, is f of x plus g of x. So what I'm going to do is I'm going to substitute the values of these functions into this formula and then combine like terms. So we have 4x squared plus 3x, that is what f of x is, and 3x to the third minus 2x is g of x. Combining like terms, namely the first degree terms, we're going to have 4x squared plus x to the third. And then if I rewrite this in standard form, with the powers in descending order, I'll have 3x to the third plus 4x squared plus x. So remember the 3x and the negative 2x combined to give you this middle term right here. So there you go with the sum. Alright, for the difference, f minus g of x, that is, using the formula is f of x minus g of x. You have to be really careful here because anytime you're subtracting a function, you have to distribute the sign to all the terms of the function that you're subtracting, which will create an inversion of all these signs, okay? So if I plug in f and g into this expression, on the right side, I'm going to have 4x squared plus 3x, which is f minus 3x to the third minus 2x. Now I'm going to distribute this negative. Imagine there's a 1 here. I'm going to distribute this negative to these two terms, and that's going to give me negative 3x to the third plus 2x. Combining like terms, namely 2 and 3, and rewriting in standard form, we're going to have 3x to the third plus 4x squared plus 5x. Alright, let's see product. What is f times g of x? Well, the formula tells us that f times g of x is equal to f of x times g of x. So all we're going to do is we're going to plug in these two quantities next to each other for f and g, and then we're going to find the product. Okay, so how do we find the product? We distribute, right? Twice, or you FOIL out. So we're going to go first, outer, inner, and then last, all right? So remember, anytime you're multiplying exponents, you add the powers and multiply coefficients. Applying that idea, let's go ahead and resolve this product of two quantities. So 4x squared plus 3x to the fifth is 12x to the fifth. 4x squared times negative 2x is negative 8x to the third. 3x times 3x to the third is 9x to the fourth minus 6x squared. Let's just write it in standard form because there are no common terms to be combined. So we have 12x to the fifth plus 9x to the fourth minus 8x to the third minus 6x squared. Now the quotient f over g of x, for that one, we just apply the formula. F over g of x is basically f of x divided by g of x. So we have the numerator being f and the denominator expression being g. We'll factor the numerator and the denominator. If they're factored, you notice that nothing can be reduced, so we just leave it that way. But we have a constraint on the domain. which is that the denominator cannot be 0. So if I solve for x by adding 2, dividing by 3, and rooting both sides, I'll have x cannot be the square root of 2 over 3. If it is, you have a 0 in the denominator, which is an undefined output. Alright? Okay. Alright, moving right along. Composition of functions. Now, given two functions f and g, the composite function f circle g of x is equal to f of g of x. So basically what we're doing here is you're plugging in g into f if you have f composed with g of x using this symbolic notation, okay? So this is the output function, this is the outer function or the parent function, and this is the input function. Alright, so let's go to the procedure in composing functions. So these are the steps for composing functions. First thing you want to do is write down the formula, namely f circle g equals f of g of x. Whatever function comes first, you write on the outside as a parent function, and whatever function comes second, that's your input function. So after writing down your formula, you then write down the first function, which is a parent function, and you replace the x's in the parent function with parentheses with the goal of inputting the input function into the parentheses, okay? After replacing the x's with the parentheses, then you plug in the inner function into the parentheses on the left, and then the value of the function into the parentheses on the right side, okay? After doing that, just simplify using your algebraic rules, and that will give you the composition of f and g, all right? Now let's try out some examples. Question 2. Find f composed with g and the reverse composition g composed with f for f of x equals x squared minus x and g of x equals 2x plus 3. So we're going to use the rules that I indicated earlier as our guide or reference on the side here. The first thing we want to do is let's write down the formula of what we're looking for. We want to find the first part, which is f composed with g, and the formula tells us f composed with g is f of g of x. The parent function f of x is x squared minus x. We're going to get this function prepped to receive the input function g by following the next step, which is replacing all the x's with parentheses, okay? So now I have the x's taken out. Now I'm going to make the following substitution. G of x, which is the name of the input function, goes on the left side, and then the value of the input function 2x plus 3 goes on the right side into both parentheses, both x parts as inputs. Now from here on out, we just use the algebraic rules, laws of exponents, to simplify this expression, okay? So since we have a square, we're squaring the quantity 2x plus 3. That simply means I'm going to multiply 2x plus 3 by itself, and then I'll distribute this negative to both quantities on the right side, okay? We're just simplifying this algebraic expression. So when I do first, outer, inner, last, for the product of these two identical quantities, I get 4x squared plus 12x plus 9, and then minus 2x minus 3. And then when we combine like terms, namely 12x and 2, and then 9 and negative 3, we'll have 4x squared plus 10x plus 6, and that is f composed with g. Okay? Alright, now let's go ahead and try the reverse composition. What if we wanted to find g composed with f of x? In this case, g of x is going to be the parent function, and f of x will be the input function. So there goes the formula for our guide, the formulas I showed you earlier. If you use these formulas over and over again, they become second nature, so you don't have to refer to them once you gain mastery of the procedure. So first thing I'm going to do is write down the formula. G composed with f of x equals g of f of x. Now what's the first function that comes here? G comes first. It's the parent function. So let's identify it. We've identified the parent function as g of x, which is 2x plus 3. Now we're going to get the parent function prepped to receive the input, which is f of x. We'll do that by clearing out the x's from both sides of the equation. Now, on the left side, we're going to put in the name of the input function, which is f of x. like that. And then on the right side, the value of the input function, which is x squared minus x, gets placed in there. All right. Now just use we just simplify this equation by using some algebraic rules. So we have 2 on the outside. We just simply distribute the 2 to these two quantities on the parentheses. And then we have g of f of x equals 2x squared minus 2x plus 3. And that gives us a solution for g composed with f of x. Okay? So thank you so much for taking the time to watch this video. You can subscribe to my channel by clicking up here. More videos can be found on mythreadserve.com. Thanks again and have a wonderful day.